The vision of ComPat is in a few sentences. First, we do multiscale modeling, and multiscale modeling is very broad. We see that in many of the sciences, but then you quickly find that you want to run these models on big computers. And this is where the problem starts. And in ComPat we want to offer solution to run multiscale models on high performance systems, and if possible the biggest computers you can find. Our vision is to provide generic solutions, which we call multiscale computing patterns, that will help us to use these HPC systems as efficiently as possible. The problems are huge. Usually when you read a paper about the science that we do, you may find a little footnote, oh yeah, we were running this on a big computer. On Supermog, for instance, the large parallel computer in Munich. The actual act of getting your simulations up and running on these big machines is lots of, well, let's say, lots of transpiration, lots of hard work for the people that have to do that. We want to make sure that we can alleviate these problems. We want to be able to, my dream would be that I can hit the return button on my computer and then something magical happens and my multiscale model runs on Supermog. Well, that thing between hitting the return button and there's something magical, that's actually what we are implementing currently in the ComPat project. Now, whether it will be like that, I don't think so. These are the Formula One racing cars of computing. So of course you have to do hard work, but we believe that we can offer some solutions that will help the specialists to run their simulations in a much more efficient way. So I believe that multiscale models and multiscale computing will be a major use of HPC. And there are a few good arguments for that. The way these big HPC machines are currently made, is by adding more and more processors. The biggest computer on Earth currently holds, I just learned, like 10 million cores. So how on earth are you going to use that in the face of weak and strong scaling, as this is called? We believe that multiscale models, but also using multiscale models in what we call replica computing mode, so running statistics over your inputs, that is a mode of usage that we will see more and more often. Coupled models, coupled physics, coupled multiscale models. Now, that means that there is room to offer generic solutions. And this is the solutions that we propose in ComPat. So I believe that if we agree that we need, or that a major application will be a multiscale model, then we will support, or will be able to support, the major workflows. And of course our hope is that our technology, our solutions are generic and powerful enough so that they can become, a big and important tool to be used in future HPC.